This is IBM Museum. And this video, I've got just a minimal Model 30 back behind me, and I'm actually been watching an old video. I'm going to get going, and I'll switch the video source. I'll keep the internal webcam on, but let's go ahead and switch over to the video capture of this minimalistic Model 30 that's on top. That just has the planer and the riser with a battery on it to run the real-time clock. And in this case, we can see where we get the warning about the set date and time. That 161 error gives us the clock over on the right. And then, of course, since it doesn't have a diskette drive or a hard drive or anything else, it warns us with that 601, the diskette drive error. And resume to press the F1 key. Okay, and it gives us the animation telling us to insert diskette. We're just going to press F1 once again. And that throws us into ROM-BASIC. So in this case, the video that I'm watching on the back monitor is when I use DEBUG to go through and plug in values for the Model 30 real-time clock. And with DEBUG, that's really easy to go and use the I for getting input of what that IO register is, using the O for output to a particular port and the value that you want to do. Basic, it's a little bit more, there's a little bit more of course, using the syntax to the ROM-BASIC, but I'm going to go through and do the same thing. I'm going to plug in values into the real-time clock under ROM-BASIC just to kind of show how that's done. Effectively going through and setting the clock. We're going to get rid of that clock error on boot up. We'll, of course, still get the diskette error and things like that, but it's just one more way to kind of clear an error that we see on startup. So on my video, I went through and I scrolled down. I realized it's not very visible of which one I'm looking at. I'm actually reading or viewing the fixing an IBM 7496 executive workstation and Model 30 real-time clock issue. And this is where, just with a minimalistic system of a diskette drive, maybe working on it to get and run DOS debug. If we didn't have the diskette drive on like the executive workstation, doesn't have a hard drive, so we get thrown into ROM-BASIC normally. And so I've gone through and I've made a cheat sheet just writing down what fields are for the minute, the hour, the day of the week, the month, the year. I mean, we could put valid values in there of some other time, but we're going to go through and actually do it for the current time that we have, that I do have locally here right now. So the lower values, the E0, IO port E0, E1, E2, those are just microseconds and milliseconds, all that. We don't need to really mess with them. We're going to go through to go to the minutes of the hour first. And this should track along as we go through. I mean, we could probably go more of saying the date first and then going back through and just to set the time. But I'll have a little investigative program that we're going to go through and track things later on. So for doing, and we're going to just do immediate values out of ROM-BASIC. So normally for going to output to a port, we give it we just say out and then space, and we're going to use hexadecimal, so that's N the ampersand H that knows that ROM-BASIC is working with a hexadecimal value. In DOS debug, we don't have to do that because DOS debug works natively with hexadecimal. So we're going to say E3, and hex E3 means that IO port E3 that normally holds the minutes of the hour. And so I'm going to do a comma, and then I'm going to do the value of 55. And so normally we want to go through, and for BCD coding, we also want to do the ANHEX 55, and then press the enter key. It tells us, okay, it didn't give us a syntax error or anything like that. We're going to move on to the next field, which is the hour in the IO port register E4. And we're going to go through and just say and hex, and going through for a military time value of 21. Okay. Going on to the E5 IO port register E5. That is the day of the week. For Thursday, we're just going to put a value in there of 5. And that's a value that's below 10 in this case. We can actually just give it, rather than just saying, I mean, hexadecimal 5 is equal to decimal 5. So we'll just put 5. We're going to move on to the and hex E6, which is our day of the month. And that will be and hex 30. We're going to go through to the hexadecimal E7, which is the month. And the same thing, we can give it a value of 3 for March. We don't have to go in there and say, you know, hexadecimal 3 is the same as decimal 3. Okay. Going on to IO port E8. Now that is the value of the century. In this case, they're only using IBM set it up to where there's just a bit for which century it is, and whether that was odd, being 19, or even, and that's a high order bit in that IO port E8 register. And so effectively C0, which you have to give the AND hex C0, is the value that we want to use for the century of 20. Okay. And moving on to and hex E9, and that is the year of the century. So that will be and hex 22. Okay. And the next values, they just may be magical numbers for the running of the real-time clock. I went through and I just plugged in when I was plugging the values under debug. I just went through and used the values that I saw that worked with the system. So we're going to the EA hex IO port. We're just going to do a value of 0. We're also going to do that for the EB register, excuse me, IO port EB. Going to do 0. Going to do hex EC, a value of 0. Okay. And then for the ED, IO port ED, I saw the value of 0E in that port. So we're going to go and hex 0E for the and we're almost done here. We're going to go through to the IO port EE hex, and we're going to write the value of FC to that IO port, and then for the last IO port register of EF hex, we're going to do a value of FF. Okay, so going through, and we could do a print, and we want to get the input of a port. So we'll do the port, IO port E3 of the minutes. And we're going to see if that's incrementing. Okay. And it's cycled over to 1. And there's a reason for that, because we've gone through and we've bypassed the hour that as I went through and took the time of writing values to those other ports. And so for the day of the month, excuse me, no, we want the hour, E4. I'm not going to stay around here long enough to pass the midnight for a new day just to see that this is updating. So here is the hour. And so we do it this way. Let's go through. And we're going to do a hexadecimal string of the input of the hex E4. Okay, so 22. So it's after 10 p.m. at night. I have to make sure that I do this in the correct way. And so for my little program that I'm going to do, I'm just going to do a 10. Let's go through and just print a blank line. I could normally go through and clear the screen or something like that, but that's fine. For our 20, we're going to say for I equals and hex E0 to and hex EF. We're just using the hexadecimal values straight away in our for loop. And so we're going to go through, and for line 30, we're going to say print. We want to see the hexadecimal format returned. So we're going to say as a hex string. We're going to do an input from I, and we don't have to give it any other value because we've got those values of going through from the IO port E0 to the IO port EF hex. And we're going to give it 2 ending parens that we need for the line. We're going to put a semicolon. We're going to put a plus, and we're going to effectively put a space in there and then a semicolon. And basically that's going to print the values just all on that same line. You'll see the output here in a moment. Okay. And we're going to go through, and for line 40, it's going to be next I. Line 50 is just a print of a blank line. Just give us a little bit of space for our output to see it on the screen. Okay, if we do a list, there is our program. In fact, we can let's do a clear screen. Let's do a list. And there is our program that we're going to run. So when we do F2 to run it, we're seeing the values. And of course, for the fields, it doesn't go through and fill in 2 characters if it's a low enough value. But we see for that E0 and E1 and E2 values that we're not really interested in microseconds and milliseconds and things like that. When we do get to that E4 value, and so that being 5 minutes after the hour is, well, okay, and so so E3, it's gonna be E3 is minutes, which has got that first value of 5 in there. E4 is the hour, which we've got 22 after 10 p.m. So it's effectively 10:05. We could go through and we could run it again. We would even see that increment. So, and during even the time I'm talking, the minutes has gone from 5 to 7. We could go through and following like the seconds, to see that minute turnover. That's the E2 value is actually the seconds. E0 and E1 are milliseconds or microseconds and milliseconds respectively, excuse me. So if we run it again, we're still on minute 7 in this case. Okay, we just went through to 10:08 p.m. Moving over to the next, the 5 after the 22 to the E5 hex IO port. We have that value of 5 that we put in for Thursday. We've got still the 30th day of the month in that E6 IO port register. We've got the value of 3 in there for the E7 hex IO port, which is March. And then we have the century value in there, the 20. And then 22 for the year century in the E9. And then those values that we wrote in, just that appear to be a working values, or I'll learn more about them with the examination of other correctly operating clocks to kind of see what those values may in fact mean. So we've got the effectively the real-time clock set. I mean, it's going through and it's tracking along even with the current time and date for the values in there. I could even go through and power this thing down, put in a diskette drive that works, going through to boot to the star diskette or to DOS, and we should have that value, that correct time and date that would show up. So just as a test of that, if we do a Control-Delete to reboot the system, we only get the diskette drive error now. And we can go through to F1, still throws us all into the ROM-BASIC ultimately. And there's no way of really going through and verifying, since that date and time values in ROM-BASIC. If we do like a print the time, that value is effectively zeroed out. The ROM-BASIC time and date is wholly independent of the real-time clock values. It can be set from it within ROM-BASIC, but it doesn't reflect the settings that are on the real-time clock at all. Totally independent of that. But this does go through enough to show that we've gotten rid of that real-time clock error just using the ROM-BASIC, plugging in values into the real-time clock so we don't have it complain. And it just so happens that we plugged in the current values that would track that. If I leave the system and go through and put in a diskette drive later, that might be good for the next video or something like that. Some other way of going through after I power down the system and powering it up with the diskette drive and actually going through and checking from DOS. In fact, let me see if I can do that. Okay, back out to the camcorder shot, just to show I went through and actually, easy way to do it, I grabbed the working drive from a Maximal 30, had to go through and, of course, grab the diskette drive cable. I need to locate where I've got those around, so I've got spares. I don't have to switch in between machines. But I've also got the 7496 executive workstation diskettes I made. These are double density. They're 720 KB. The boot diskette, and then I've got the diagnostic and the scratch. And even though this is a 1.44 megabyte drive, in fact, this setup would actually, with the diskette drives I have otherwise, would be a good way to go through and test to see if I've got some other diskette drives that I can lay my hands on for like the 720 KB, just going through and testing. I'm going to put the boot diskette in there for now. And that has that MS-DOS files to go through and boot. And let's go through and get switched over to the video capture. Get powered on. Since we do have a diskette drive that should work with this unit, in fact, we'll see with that revision 00 if the high density diskette works from that machine. Didn't get a diskette drive error. Okay. And interesting, for some reason, I mean, we loaded, oh, I know what that is. So the MS-DOS 6.22, I've got some pretty low memory on the system. I'm not going through and I don't have those sims populated. And DOS 6.22 probably needs more than 128 KB. So we'll go through. I don't think So let's take seeing how we were able to boot, rather than switching over the sims, let's go through and see if the diagnostic diskette. And I don't know if there's a place on there that for the diagnostic that of referencing the date and time, but we'll see. I can't remember enough of that diskette previously, but it seems like it loaded it with just 120 KB. Okay, so we do have that set time and date. Excellent. We don't have to switch sims here. I mean, I don't like working with that as much either, because the latches for those sims are plastic. They're really brittle. So let's get through and do set time and date is number 4. Press enter. Okay, the current time is 22:20. Okay, and that is correct. So we're going to press enter. The current date is the 30th of March, 2022. And that is also correct. So we have all that time and date set from here. We do a, this is just amazing. This is able to run on 128 KB. I don't know if it'll show, it'll probably prompt us if the, okay. And even here for the, it counts that effectively as 162 KB of memory. Pretty minimalistic, but it does detect that the keyboard display has the 1 diskette drive. Doesn't really talk about the aspect of the 1.44 megabyte drive, diskette drive at this point. But it was able to boot. It recognizes that drive just fine. And so, I mean, we've gotten through the time and date error just by plugging in values from ROM-BASIC, and then went through and connected a diskette drive to boot from that. We learned that MS-DOS 6.22 needs a little bit more RAM to run than 128 KB. So I'm glad that that diagnostic diskette of that 7496, which has the MAL 30 planar in there as well, it's able to run from not even having sims installed, just that planar soldered in RAM of 128 KB. So the list is correct. We don't really need to go any further to say, I mean, we can tell it yes. And I don't want to go through for the, for the diskette, or all the tests that we've needed to be done, they're done. So if you enjoyed the video, go ahead and click on that like button, please. I'll go through and wrap up this once I got the video over, can do this outro. And as always, subscribe to my channel if you've not done so already. Just another video, odd content, we can do that. And so recommend it to your friends if they like this sort of odd content too. But this is IBM Museum. That's all I have for now. Thank you.